Okay. Okay, well, welcome to the course, Advanced Machining Process. If anybody has any doubt, you can ask me. I have seen the doubts regarding in that Excel sheet. Some of you have posted there, but I don't find anything relevant there. Okay, somebody asked about Mastercam, but what Mastercam? This Mastercam is not included into the syllabus, so I did not keep Mastercam as a learning session in this course. Uh, Somebody asked as a girl student means in manufacturing, she wants to do master degree. So what subject he or she should take? So I shall suggest new topics, the subjects related to the current affairs, like you can select this micro machining or micro manufacturing as one of the courses. Okay, so because these things are actually hot cake right now, and other topics you can consider as 3D printing. So 3D printing, metallic 3D printing, or any rapid prototyping, any name. So all names are similar. So concept wise, it will be similar. So you can consider this one 3D printing as one of the subject, and some basic subjects also you have to take. Okay, so like in our institute, there is a course which is called actually subtractive manufacturing. So all the new areas of this subtractive manufacturing in metal containing advanced machining process, it is included there. Okay, so you can consider that kind of course also. Okay, so other basic subjects like metal forming, that things also required, and mathematics obviously if you are going for higher study, so mathematics is one of the subject you can consider. Somebody asked regarding the question papers. So I shall request to go through the whole subject, means whole syllabus. What about video lectures I have given? So everything is included there. Okay, so I shall I have included from entire syllabus basically. So it is not like that you study this ECM or EDM, so it will not helpful. Okay, so it is better you go through all the subject, entire syllabus. Okay, so from entire syllabus, only basic questions I have asked, not in deep questions, and some numerical actually I have asked. So you have to really apply your thought. These numerical questions are actually it is kept to separate out the top students. So the top scorer. Okay, so it will separate out from the top scorer from the average scorer. So numericals you have to, yeah, you can go through that. So exam pattern right now I told exam pattern. So you have to consider entire syllabus. So it will be actually a multiple choice MCQ type. So so okay. So you have to consider you have to go through the entire syllabus of this course. So it is a MCQ type, and only basic questions I have asked, few basic questions. So if you go through the videos, then you can consider. I already given the slides. The slides they are actually really helpful. So mostly it will come from the slides, and some numericals regarding the concept. Some equations I already solved during the video lecture. So from there actually few numericals will come. So if you go through the subject very well, then you can easily you can do that. So any other questions you can ask me. If you have any other doubts. You have a very limited time, so it is better you if you have any questions. Okay, thank you. So I am preparing for GATE. Is we expect all the topic that covered in the syllabus, or it is more than this course on advanced machining topic. So regarding this course exam, I can tell you what regarding this GATE. Uh, Regarding if you consider this last 10-year question, you will find that mostly people asked in advanced machining process, mostly in ECM and ADM process, and few questions I have seen regarding that ultrasonic machining process. So other than these three topics, other topics people generally don't consider in GATE. So if you are preparing for GATE, then you can forget ECM, EDM, and ultrasonic machining. These three topics are more than enough, I think. But this advanced machining process, it is a PG level course. So those who are willing to work in the area of advanced machining process or non-traditional machining process, so this is an introductory course to make you aware about the different advanced technologies, advanced machining technologies, which is nowadays used in different industries. Okay, any other question you can ask me right now? Okay, so we have a very limited time, so maybe you can ask. I shall try to answer. No, it is MCQ type, so all questions are MCQ type. All questions are MCQ type. Numerical type I have converted to MCQ type. So whichever is the right answer, you have to correct. Means you have to take that correct answer only. For numericals also, I have given few numericals. For numericals also, I have given the answer. So different options I have given. Out of all four options or three options, one option will be correct. So after solving the numericals, which one will get? So the nearest answer will be your. Means you have to click the nearest answer. So few numericals I have given, only very few numericals. So this is these numericals are little bit tougher than whatever this normal MCQ questions. Okay, to separate it out, the best candidates or best students out of all 500, I think around 500 students are appearing for this exam. So if you have any questions, you can ask me quickly. How can you find a specific removal rate, metal removal rate, in terms of atomic weight, density, and valency? So that equations is already there. Huh? So in case of this ECM process, metal removal rate, it depends on the current passing through the electrode. So and then it depends on the electrochemical equivalent weight. So how much current passing through the electrode, so and how much electrochemical equivalent weight uh, of that material. So for the different materials, electrochemical equivalent weight will be different. Okay, so from there actually electrochemical equivalent weight can be calculated as atomic weight by valency. Okay, so atomic weight and valency means it will be different for a different material. Okay, but electrochemical equivalent weight it will be specific for a certain material. So you have written that electrons. So in terms of electrons, you can consider this one is metal. So if your metal is actually an alloy, in that case actually this what proportion of this alloy is present in that material, accordingly actually your density means you have to calculate density accordingly. So so from there itself you can easily calculate that actual material involved, but you have to know actually current, how much current is passing and for what time. So basically it is a amount of current passing through the electrolyte, so it is current multiplied by time. So radiation operation of this FF is so radiation. So this in average flow finishing process actually it is used for actually for radiation purposes also. So in that case actually if you are using, so it may be actually for removal of the bars, it may be for actually radiation operation. Suppose there are one joint is there. Okay, so two pipes are there, they are connected. Okay, so in their connection, so it may be actually connected by welding process. So you'll see that actually lots of bars are will be there, undulations will be there, their slugs will be there, which is during welding process. So that thing actually it has to be removed before using that for smooth flow of the fluid, for which purpose it is used. So for radiation purpose, you have to choose the media which is actually soft media. So soft media is used for radiation purpose, but in case of actually finishing of long holes, so in that case actually you have to use hard media. So but soft media is used for uh, radiation purpose in AFM process. So radiation I already told there are it is a connection between two pipes. So it is welded together. Okay, so in that case what happens actually this corner portion, so what is the connection between two pipes there, so there should be a smooth flow of fluid from one pipe to the another pipe. So in that case actually this radiation operation is conducted. Okay, I hope I have answered your question. So you have to use soft media in case of this radiation purpose in AFF, average flow finishing process. Okay. So for default drilling, actually you can use step tool electrochemical machining (STEM), stepped tool electrochemical machining. Okay, so it is already discussed. In normal ACM process, actually that is a shallow hole is generated, but in case of the step tool electrochemical machining process, so one glass tube actually it is inserted inside that yeah, where you want to do the machining operation. So it is a that electrolyte which is actually different than a normal ECM process. So in normal ECM process, whatever that metal hydroxide actually generated or developed metal hydroxide or debris particles, it comes as a debris particles. Uh, but it does not mix with the electrolyte. Okay, so but in case of this kind of step to electrochemical machine process, this whatever this metal hydroxide which is generated, so it dissolves into that electrolyte itself. So acidic electrolyte is used in case of this step to electrochemical machining. So it is called actually STEM. So this is the best process, but other process you can use, but that is not that much. You cannot get straight hole Okay, so long aspect ratio holes. Laser, in case of laser, very high aspect ratio holes you cannot get, but the shape tool electrical machining, it is the best process basically. So solid state laser, you know that all the solid state laser mostly they are actually their power capacity. This power is very less. So mostly like ruby laser you see. Okay, so they don't have actually that much power. So using this solid state laser with small power, suppose 200 watt, 300 watt. So you can do only small micro machining purpose or joining of thin shades, making small holes, that kind of thing you can do. But for heavy duty work, for suppose for joining 3 millimeter, 4 millimeter, 5 millimeter thick titanium of grade 5, okay, titanium alloy. So in that case, you need at least 800 to 900 watt or more than 1 kilowatt is required basically. 1 to 1.5 kilowatt it is required. Okay, so you can consider in that case actually this fiber laser, that kind of laser you can consider. Okay, or CO2 laser you can consider, but with a solid state laser, mostly they are actually very power means wattage is very less. Their laser power is very less. So in that case, actually, it is very difficult for heavy duty purpose. Means suppose joining of thin plates or drilling of very thin, I'm sorry, thick plates. It is very difficult. I hope you got your answer. So any other question you can ask? So I've given few references like advanced machining processes by Dr. V.K. Jain. He was ex professor from IIT Kanpur. V.K. Jain, Advanced Machining Processes. So that book you can follow. So it is a good book actually, comprising almost all advanced machining processes there. Okay, so you can follow that book also. Okay, if you have any questions, you can ask. What will be the weightage of assignments in final NPTEL exam paper? Weightage, actually, right now I cannot remember. So it may be decided by NPTEL itself. Exactly, I don't know. It may be 50-50. assignment and this final exam, it may 50-50. Uh, right now I cannot comment on that. What is ultrasonic assisted turning operation? Okay, so there are suppose if you want to do this machining of this brittle material. Okay, so like suppose you are machining of this quartz, glass. So these are actually very brittle material. So in that case, if you see that actually, if you go for this turning operation, so they don't have actually this yield point basically. They fracture. So generally, all these kind of brittle materials they fracture. So in that case, your this depth of cut it should be very low. It should be very low. And also, if you put some certain kind of ultrasonic means vibration into that during turning process, so in that case, actually you can do the machining into the ductile resin. So means you are doing this actually machining of this brittle material in the ductile reserve. In that case, you cannot say that actually this fracture will not be there, but you can reduce significantly. You can reduce that fracture or cracks, whatever is generated. So you can reduce that thing. So that's why actually this ultrasonic assisted turning, so it is not, it is like a normal turning, but this tool it is vibrated ultrasonically. So ultrasonic vibration means it is more than 20 kilohertz, so it is beyond the human ear. So in that case, you can do the machining into the ductile region. So mostly actually these brittle materials which are machined using this ultrasonic assisted turning or ultrasonic assisted milling operation, it is used. सेशन खत्म होने के बाद डाउनलोड व्हाट यू वांट टू डाउनलोड so it is not clear Mr. Sarvaiya, so what you want to download? This PPT file I already gave, so you can download anytime. I already given there, so this PPT file is already there, so you can download anytime. All those 50 files are uploaded there in that NPTEL site, so you can download anytime. Video lecture contains a lot of out of subject material is necessary to study it. I think whatever given in that video lecture, so everything is important. Okay, so nothing is out of subject. So first one is electrically machined surface, high residual stress and improved fatigue strength. So first one is not correct because in case of actually ECM process, what happens actually this base material or to this anode, which is uh, anode actually this there is a anodic dissolution of this material. Okay, so in case of suppose in grinding process because of this grinding operation there is a compressive residual stress generated. So for grinded material, there is a fatigue life of this material actually it increases because there is a compressive residual stress which is generated. But same material, suppose if you do that same process, whatever this initial layer means this upper layer of the workpiece where this compressive residual stress is generated by grinding process, it is removed and the work material comes to a actually norm base material basically. So we cannot say that actually there is a improved residual stress. So residual stress, if at all it is there, it actually reduces basically. So second one is the correct actually. See, insignificant residual stress and reduced fatigue strength. And small actually this porosity, little bit of porosity is in a very small amount, although in case of this ACA process because of these chemical reactions of this electrolyte with the workpiece material. So in that case, there is a small damage of the workpiece because if there is affinity with of reacting the workpiece material with the electrolyte, so in that case a little bit this workpiece surface will be damaged. Other than machining, so other surfaces will be damaged. So that's why people use certain kind of mask in other places so that it should not damage the area where it really there is no need of machining. Okay. So I think I already gave the answer. Pattern already I told it will be an MCQ type question. Okay, so few questions just like actually introduction of the process. If you know the process, then you can answer. Okay, so and so all questions, I think all these kind of questions you can answer very easily. But few questions I have given regarding that numerical, some numericals I have given. So in some processes, actually some equations which we have used there while explaining the process. These numericals are based on that actually whatever equations we have used there where material removal rate, surface finish also how to calculate that those things actually I have shown. So if you have studied that equations there regarding the modeling of that process and that kind of thing will come in numericals. So these numericals are little bit tougher than normal process, normal questions. Okay, so if you go through that actually whatever this modeling of that process, individual process, then you will easily you can answer all these questions. So this timing, I think it is the 3 hours, I think. So I don't have any idea. So it may be 3 hours. It may be 3 hours, I think. 3 hours. Huh? So it is 3 hours question. But if you know all the answers, then it will be completed within maybe 2 hours. It may be completed. Only numericals will take a little bit of time. Okay, so other than numericals, other things are very easy. So that's why I'm telling. So you prepare for the numericals, it will be better. So in electron beam machining, what effect does accelerating voltage on beam current? Beam current and it has effect on material rate. Okay, so depending on your beam current, actually this material rate increases in case of this electron beam emission process. So that's why actually beam current it is very much important. No, no, there is no negative marking. No negative marking are there. So all questions are very easy. So I don't think of actually negative marking. You can easily answer all the questions. Only numericals I told. Numericals you just go through the numericals. Okay. Whatever equations I have given. So you just try to remember those equations. You can wherever this modeling of the process is there, material modeling, thermal modeling, all these things I have shown. So there are some equations if you remember, or you can make it in your own during exam itself, and you will be able to answer all the questions. So I think no more questions are there. So maybe you can stop. So I think no more questions are there. So we can stop here. If you have any question, you can ask. In that portal itself, you can ask, and our TS and myself, we shall try to answer all the questions if we have in the later.